Good morning, dear students. I welcome all of you to my video lecture series on the foundation of physics. Today, I shall talk about the physical quantities and the units of measurement. I shall show you the outline and the write-up of my lecture. Also from the background, I shall elaborate the various components of the outline for your systematic and sequential understanding of the topics. While listening to my lecture, please do not take down any notes so that your attention and concentration are not disturbed. However, you may take a printout of the outline and the write-up of my lecture for your future reference. To start, here is the outline of my video lecture on the physical quantities and the units of measurement. It is in one page. Here is the write-up of my lecture. It is in 2 pages. Dear students, to elaborate, physics is a branch of science. It deals with the basic laws which govern various natural phenomena. Physics uses certain measurable physical properties for expression of its laws and formulae. Any measurable physical property of a body is called physical quantity in physics or simply quantity. Physical quantities are of two kinds. One is base or fundamental quantity and the another is the derived quantity. For the sake of brevity, I shall use the word quantity in place of physical quantity. Base quantities or fundamental quantities are those quantities which are, base quantities or the fundamental quantities are those quantities which are independent for their measurement and expression. These are 7 in number. They may be considered as the 7 letters of the physics language. The 7 base quantities are length, mass, time, temperature, electric current, luminous intensity, and amount of substance. Here amount refers to the number. Derived quantities are the quantities which are dependent on or more base quantities for their measurement and expression. All quantities other than 7 base quantities are derived quantities. For examples, area, volume, density, speed, force, work, etc. A quantity which has only magnitude and no direction is called scalar quantity. For example, mass, time, distance, speed, etc. Magnitude of a scalar quantity is always taken as positive, whereas a quantity which has both magnitude and direction and which obeys special rules of vector algebra is called a vector quantity. For example, displacement, velocity, acceleration, force, and so on. The magnitude of a vector quantity may be positive or negative, depending upon its direction. We follow the standard conventions of Cartesian coordinate system of XYZ axis and rotational motion to determine the positivity or negativity of a vector magnitude. Accordingly, a vector magnitude is taken as positive when it is directed horizontally rightward, vertically upward, above surface, and rotationally anticlockwise. Similarly, a vector magnitude is taken as negative if it is directed horizontally leftward, vertically downward, below surface, and rotationally clockwise. To recall, any physical property which can be measured is called physical quantity or simply quantity in physics. The word measurable is very important. Then what is measurement? Measurement of a physical quantity involves comparison with an arbitrarily chosen and internationally accepted standard reference called unit. The measured value of any quantity is expressed as the combination of magnitude, which is expressed by a number, and a unit. For example, if you say that the length of a rod is 5 meters, here 5 is the magnitude and meter is the unit. The units of the 7 base quantities are called base units. They are independent and they can neither be derived from or can be resolved into any other units. The units of the derived quantities are called derived units. They are derived from the defining equations of the concerned derived quantities in the form of base units. In addition, there are 2 dimensionless purely geometrical units called supplementary units. They are radian, it is used as the unit of plane angle, and steradian, it is used as the unit of the solid angle. A complete set of units, both fundamental, that is base, and derived, is called a system of units. There are 3 old systems: the CGS, that is the French system; the FPS system, that is the British system; and the MKS system, that is the metric system. They are not in use now for the sake of uniformity. Now at present, for the sake of uniformity, the international system of units called SI system is internationally accepted and widely used throughout the world. Accordingly, SI units of 7 base quantities are: for length it is meter, for mass it is kilogram, for time it is second, for temperature it is Kelvin, for electric current it is ampere, for luminous intensity it is candela, and for amount of substance it is mole. For examples, the SI units of some derived quantities are meter square for area, meter cube for volume, kg per meter cube for density, meter per second for velocity, meter per second square for acceleration, kg into meter per second square, that is called Newton, for force, and joule for work, and so on. We have to follow certain standard rules and guidelines for writing the names and symbols of units. In brief, the unit names are never capitalized with small letters. The unit names are never capitalized. As for example, the unit of force is Newton. But when you write the Newton as unit, then we have to write N is a small letter. The unit symbols are written in lowercase, starting with small letters. 3, third, then unit symbols use only singular form and remain unaltered in the plural. So we cannot say 5 meters, you have to say 5 meter only. The unit symbols do not contain any final full stop, and the unit symbols are capitalized only if the symbol for a unit is derived from a proper name of a scientist, that is Newton, Joule, Pascal. That means N is a capital for Newton, J is the capital letter for the Joule unit, and so on. In short, the unit names must be small, it should not be capital, and unit symbols should be in the lowercase. It is always singular and it contains no full stop. If unit names are abbreviated, then if it is from a proper noun, proper name, then only the capital letter is used. Otherwise, it should be small letter. Dear students, this is all about today's video lecture. Hope you have got certain basic idea about the physical quantities and the units of measurement. To sum up, physics deals with the basic laws of natural phenomena. Physics expresses its laws and formula in terms of certain measurable physical properties. Any physical property which can be measured is called physical quantity or simply quantity in physics. Physical quantity are of two kinds. One is fundamental quantity or base quantity, another is the derived quantity. Base quantities are those quantities which are independent for their measurement and expression. They are 7 in number. They are length, mass, time, temperature, electric current, luminous intensity, and amount of substance. Here amount refers to the number. Derived quantity are those quantities which are dependent on one or more base quantities for their measurement and expression. For example, area, volume, density, and so on. The quantities which have got only magnitude and no direction are called scalar quantity. Scalar quantity magnitude is always taken as positive. Again, the quantities which have got both magnitude and direction and which obey the rules of vector algebra for various mathematical operations like addition, subtraction, multiplication, division, so on, are called the vector quantities. The magnitude of vector quantities may be positive or negative depending upon its directions. To determine the positivity or negativity of a vector magnitude, we follow the standard convention of the Cartesian coordinate system of x, y, z axis and rotational motion. Accordingly, a vector magnitude is taken as positive if it is directed horizontally rightward, vertically upward, above the surface, or rotationally anticlockwise. And a vector magnitude is taken as a negative if it is directed horizontally leftward, vertically downward, below the surface, and rotationally clockwise. To repeat, any physical property which can be measured is called a physical quantity or quantity. The question is, what is measurement? Measurement of a given amount of a quantity is nothing but its comparison with an arbitrarily chosen and internationally accepted standard reference. And this standard reference is called unit. Any measured value is expressed as a combination of two things, that is magnitude, which is expressed as a number, and a unit. For example, if we say the mass of a thing is 5 kg, here 5 is the magnitude and kilogram is the unit. The units of the base quantities are called the base units. Thus, there are 7 base units. They are independent, and these units can neither be derived from any other unit, nor it can be resolved into any other unit. The units of derived quantities are called the derived units. They are derived, the derived units are derived from the definition of the derived quantities in the form of the base quantity. In addition to the base units and derived units, there are 2 supplementary units. These two are dimensionless and purely geometrical units. They are radian as the unit of plane angle, and steradian, which is used as the unit of solid angle. A set of units, that base units and derived units, is called the system of units. We had the old system, they were 3 in number. One is CGS, that is called French system. Another is FPS, that is called British system. And the third one was MKS, that is the metric system. Nowadays, for the sake of uniformity, these 3 old systems are not in use. Now, the international system of units called SI system is used internationally for the sake of uniformity. So SI system is internationally accepted and widely used throughout the world. Accordingly, the SI units of 7 base quantities, that the 7 SI base units are: for length it is meter, for mass it is kilogram, for time it is second, for temperature it is Kelvin, for electric current it is ampere, for luminous intensity it is candela, and for amount of substance it is mole. Similarly, for examples, the SI units of some derived quantities: meter square for area, meter cube for volume, kg per meter cube, that is for density, meter per second for velocity, meter per second square for acceleration, and so on. There are certain standard conventions for writing the names and symbols of units. In brief, the unit names are never capitalized. Even though it is a proper noun, proper name, scientist name, it is never capitalized. As for example, the unit of force is Newton, but when I write it as its unit name, then N must be small. The unit symbols are always written in a small case, in the lower case. They are never plural. They never contain any full stop. And they are always singular. For example, if you say the length of a rod is 5 meters, you cannot say 5 meters. It has to be said 5 meters only. Dear students, I strongly advise that you must memorize the definitions of all the technical terms used in physics, and also all the laws and the formulae of physics. You should revise those regularly, and you should also inculcate the habit of writing from your memory for perfection and confidence in the exam hall. You should also practice the given theoretical and numerical exercises for building your confidence in the exam hall. Dear students, I thank you very much for your patient watching and listening to my video lecture on the foundation of physics. If you like my video lecture series, I would request you to subscribe to this channel. I sincerely hope that you will participate in my video lecture series on the foundation of physics with keen interest and attention, and I am sure you will stand benefited immensely. Dear students, the video ends here. Thank you again